These examples come from Delta Math, factoring trinomials where a equals 1. That just means our leading number right here is going to be 1. The instructions for this section just say to factor. So when we factor trinomials, we're going to be looking for two numbers that multiply to be this last number, and that same pair of numbers that we choose has to add up to be this middle number. So I'm going to start with the number 12. And I'm going to make a list of all the things that multiply to give me positive 12. So that could be 1 and 12. It could be 2 and 6. It could be 3 and 4. And I think that's about it. After that, we start getting into repeats like 4 and 3, 6 and 2, and you don't need to list those. However, remember to get positive numbers, you can also take negatives times negatives. So negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. So those are all the numbers that multiplied to be 12. Now there are fractions out there that could also make that happen for us, but we do not want to use fractions here. So out of these, I want to try to find the pair that adds up to be 7. So if I try 1 plus 12, I get 13. So these two are too far apart. It also means that the negative version here isn't going to work either, because negative 1 and negative 12 will make just negative 13. So those are still too far apart. 2 plus 6 is going to make 8, so we're getting closer. And we don't want negative 8 either, so that's not going to work out so good. But 3 plus 4 sounds great. That's going to make 7 for us. All right, and we're choosing 3 and 4 because remember, 3 times 4 is going to equal 12, okay, to give us that last number. And 3 plus 4 is going to give us 7, which checks out to be the middle number. Now to actually build my answer, those are the two numbers that will appear. I want to create two binomials. We're putting an x in the front of each, okay, and that's because of this x squared. We're basically taking, remember, x squared comes from x and x. We're basically taking that x squared and splitting it apart. So one of those x's goes here, one goes here. So that if I were to multiply this back through, x times x would give me x squared. So the 3 and the 4 are what are going to be the numbers that go back here in the back, and they're also going to dictate the signs that go there. So we picked a positive 3 and a positive 4. Now I could switch them. I could say x plus 4 and x plus 3. It would not change my answer. To check, you can FOIL these. You can multiply it back through, and just to make sure, x times x gives us x squared. X times 4 is 4x plus 3 times x, which is 3x. 4x plus 3x will make 7x, so that's good. And 3 times 4 is going to make 12. You can see where the 3 times 4 happens to give us 12, and the 4x and the 3x add to give us 7, which is why we're looking for this particular combination. The only change that can happen in these problems is with the signs, where we have to be a little bit more careful about the numbers and the combinations that we choose. So here, I'm looking to multiply to get a positive 10 in this next example, but I'm trying to add to get a negative 7. So I have to be a little bit more careful with what I choose. So I'm going to try to make a list for 10. So I know that I can have 1 and 10, or it's a pretty short list, 2 and 5. So similar to my list from before, I could also have the double negative versions, because those will still yield a positive 10. So then I could also have negative 2 and negative 5 there as well. So if I try to add these now to try to get negative 7, 1 plus 10 is going to be 11. That's going to give me a positive number. Negative 1 plus negative 10 will give me negative 11. So it's just a little bit too big, but it is giving me a negative number. So I'm probably going to need this guy right here. Negative 2 plus negative 5 is going to give me negative 7. 2 plus 5 gives me positive 7. So similar, but not quite right. So negative 2 and negative 5 are going to be the combination that I need. So when I build my answer, we're still going to put the x's in the front. And now we chose a negative 2 and a negative 5. So notice now that our signs are minus in the middle because we chose negative numbers. Again, you could multiply this back through just to make sure that things work out the way that they should, signs and all. X times x is x squared. This would give you negative 5x and negative 2x, which would combine to make negative 7x. And negative 2 times negative 5 makes positive 10. So that does check out. On the next one, we have a negative number here. So now I need to make a list for things that multiply to be negative 8. So remember, this could be negative 1 and positive 8, or I could flip that around and say negative 8 and positive 1. I can do negative 2 and positive 4, or that could be flipped and say negative 4 and positive 2. So thinking of the same kind of numbers that would give you positive 8, but just alternating the signs. So now I have to be careful when I add. I want to make sure that I get negative 2 as my answer for the addition section. Negative 1 plus 8 is going to give me a positive 7. Negative 8 plus 1 is going to give me negative 7, so still not quite right. Negative 2 plus 4 is going to give me positive 2, so I am close. What that tells me is that I'm probably just going to need to flip the sign and make it negative 4 plus 2 is going to give me negative left over. So negative 4 and 2 are going to be the numbers that I need. So when I build my answer, we still throw those x's in the front, and then I want a negative 4 and a positive 2. So notice that I have one of each sign. It is okay to switch the whole binomial, so this is a great answer. The other acceptable answer would be to say x plus 2 and x minus 4. So basically just taking these two things and switching them. What I couldn't say, what is no good, it would be saying x minus 2 and x plus 4. That changes, it would be using this pair right here that we eliminated. All right, one more that's similar to this last one. I'm working on a list for negative 15. So I have negative 1 and 15, or remember, negative 15 and 1. Or I think the only other option is negative 3 and 5, or negative 5 and 3. All right, if you get something like this, if I try to add, I get negative 1 plus 15 is going to make 14, so that's no good. Negative 15 and 1 makes negative 14. Negative 3 and 5 makes 2. And negative 5 and 3 makes negative 2. So I never ended up getting this positive 5 here in the middle. If you have a problem that works like this, this is called prime, where no pairs actually work. I double check to make sure that I have all the pairs that I was supposed to have, which I do, but this one ends up being prime, meaning that there aren't numbers that make that combination work.